My name is Cornelia Davis. I'm with Pivotal. I've been with Pivotal since the spin-off, Senior Director of Technology, and I essentially work in the product organization and help bring kind of our newest products to market. And I did so with PCF, did so with Pivotal Cloud Cache. Any Cloud Cache customers, users in here? Just a couple. And now I'm doing that with PKS. And so really delighted to have you here so that we can share some of that. And my colleague?
Fred Melo, also being Pivotal since the beginning. Actually came from VMware. Been involved with PCF since the very early days as well. Now partnering with Cornelia on the PKS product team. So we're gonna deliver a joint session talking both about use cases and user side of things. And then the second half, we're gonna go a little bit deeper on technology and how things are done.
Yep, right. Absolutely. So I'm going to do the high-level hand-wavy stuff, and Fred's going to do the real meat of the matter. So thanks. Super. Thank you, Fred. All right. Let's go ahead and get started. And of course, PKS, we do not spell container with a C, but we abbreviate it with a K, because that's what all the cool kids are doing. So what we want to do is, I'm not a big fan of agenda slides. Yes, I am talking about product, so I did have to keep the disclaimer slide in there. Our marketing team was really good. The template that they gave us had the disclaimer already in it, which is the only reason it's there, because I never would have found it otherwise. But we are talking about product, and we are talking about a product that we're releasing soon. And so we're going to give you our best approximations of what we're going out there. And we're releasing very soon, so this is going to be very accurate, but there's no promises. So what I want to talk about first is why. I was actually at an analyst event earlier this week with some customers as well, and we were around the table in the morning over breakfast, and somebody said, why is Pivotal doing this? So I want to answer the why of why Pivotal's doing this, and then I'll talk a little bit specifically what it is. Not the underlying architecture. Fred's going to take us through that. But really kind of what the product is and what you're going to be able to do with it from that perspective. So let's talk about the why. And let me just have an idea of show of hands. How many folks in the room are PAS, formerly known as PCF customers, platform customers? OK, actually quite a bit less than half. How many people are here because of Spring? OK, data? All right, so a whole bunch of you didn't raise your hands. Why are you at SpringOne platform? Are you at the right conference? All right, so you're just shy. That's OK. That's good to know. The reason I asked that question is because some of these things I will occasionally refer to those of you who are, know and love the PCF or the PAS product as we go along. And the why kind of gets to that, because the Cloud Foundry platform has for 4 or 5 years been providing a great deal of value to a set of customers who are building predominantly cloud native or kind of approximating cloud native applications. And you've seen many of those large customers talk about the tremendous value that they've gotten. And we have arguably generated a lot of value, helped our customers generate a lot of value from that application platform. Part of that value comes from the opinionation that's built into the platform. That opinionation drives developer productivity and operational efficiency. But I was talking with another customer this week, and they said, yeah. Oh, in fact, I think it was on the main stage. I think it was one of the first keynotes yesterday morning where they said, we have 10% of our workload running on the platform. And I thought, whoa, 10%. That is 90% that you are still running the old way. And so to answer the fundamental question of why Pivotal has built this is because our customers have asked for help running workloads other than the cloud-native workloads or approximating cloud-native workloads that they're getting tremendous value from. So there's a great number of other workloads, and I'll talk more about that as we go. So some of those workloads might be legacy workloads. They might be batch batch processing workloads. They might be already containerized workloads, things like from ISVs, those types of things. So we're starting to see more and more ISVs who are saying, you know what? The distribution mechanism for us is going to be a set of Docker containers and some templates to help you deploy them. So maybe some Helm charts or something like that. And so our customers are saying, you've helped us, with a platform that helps us gain all these efficiencies for cloud-native apps. Can you help us do it for more of our app portfolio? So that's certainly part of it. Another part of it, there we go, is it's not just the workloads. It's not just the architectures of the applications or the existing applications that you have. There's also variability in the way that you bring that software to your consumers. So on the one hand, you still have those applications that aren't being released continuously. You have a whole slew of applications that you are running in production, and you hardly ever have to change them. Once in a while, maybe every 6 months, you release a new version of that software. You do some bug fixes in it, but you're not trying to support that continuous delivery, continuous integration lifecycle. So you've got these very stable, and I put stable in quotes, of course, that applications that are in maintenance mode. And so that's kind of a software delivery lifecycle that I need to support. And then, of course, you've got these more continuous delivery ways of delivering software as well. So I didn't include it in this particular slide deck, but I sometimes talk about those as two different axes. If you think about them horizontally and vertically, that on one axis you can look at the architecture of your application from traditional to cloud native, and on the other axis we take a look at how frequently do I need to release this software? What does the SDLC look like? And then that gives you a framework where you can start to characterize your workloads into these different quadrants and start to choose the right platforms to help you bring the efficiencies that you need. And I'll talk a little bit more about that. Both Fred and I have actually done previous talks, like at CF Summit, where we talked specifically more about the workloads. What we wanted to do today is have a little bit more of an overview and a little bit more of a tech dive. So we won't talk too much more about workloads. So if you take a look at those two different applications, what's interesting about it is that on the left-hand side, you're fundamentally more focused in run. You're really focused on the operational efficiencies. And on the right-hand side, you need the operational efficiencies, but you also need the developer productivity. Now, I put those labels up there because it allows us then to start to characterize this from these workloads, from the architectures and from the software delivery lifecycle. What kind of platform are we going to use to support that? And so if we have that spectrum from the left to the right, we tend to typically have some monolithic applications on the left-hand side that are really the ones that are more in maintenance mode. And on the right-hand side, we have cloud native. So again, you can see those two different axes, but now they're kind of on this slide in a different way. Now, where are you running those things today? Pivotal customers, by and large, are running those things today on the right-hand side, the cloud-native application platform, Pivotal Cloud Foundry, or as we now call it, the Pivotal Application Service. And on the far left-hand side, what we've left you with is infrastructure as a service. Now, as you know, with PKS, we're partnering very closely with VMware, so VMware is quite happy with that solution, except that their customers are challenging them to give other abstractions as well. And so here's what we're doing, is we are adding something in between, which is orchestrated CAS. So this is containers orchestrated. So giving you some of those same capabilities that you've gotten on the cloud-native application platform on the far right-hand side, but getting it in a container-based environment, so a container dial tone. And you can see that as this built out, it said, okay, well, boy, that container, that orchestrated CAS system allows me to start pulling my my traditional applications over toward the right a little bit, and it allows me also to take my cloud-native applications, part of which might have some stateful services or some stateful characteristics or something along those lines, and start to leverage a containerized system to augment or to expand my cloud-native footprint as well. All of that, IaaS orchestrated CaaS and cloud-native application platform can run on the same infrastructure under the covers. And of course, as we announced yesterday, on the right-hand side, PCF is now an umbrella term that is that's encompassing more than just the application runtime and the set of services. It's also encompassing the orchestrated CaaS in the middle. And over time, what we believe will happen here is that more and more, you're going to be able to use that higher level abstraction and hide the traditional IaaS, compute, storage, and network underneath those abstractions that give you gains in developer productivity and operational efficiency. Okay? All right. So kind of to sum it up, so we've got these different dial tones. So one of the things that you might want to think about is, okay, well, now I've got a workload, and I've got something that I need to do. Where do I land it? Do I use PAS, or do I use PKS? Is it going to be containerized? And so you have a lot of trade-offs. And I'm going to share kind of anecdotally a story with you. And that is, some of you may know, and maybe I just saw a few of you over at the booth, that I'm writing a book. I'm writing a book on cloud native. And I've been writing it for far too long already. I'm working on it. I only work on it on the weekends. But up until about 4 months ago, it's an architecture book, and I do some code samples. And up until about 4 months ago, all of my examples, if I was pushing into the cloud, I was pushing into Cloud Foundry. And when I started working on PKS, I thought, you know what? Let me take my same code samples and get them running on Kubernetes, get them running on PKS. And so I did that, and I sat down and I took some code, and I made a few changes, not because I was moving on to a container environment, but I made a few code changes, and I was like, okay, great, now I'm going to push it. And I got my Minikube. Minikube is Kubernetes running locally on your desktop. And I got my Minikube up and running. I'm like, boy, that was easy. That was really cool. Okay, I'm going to deploy my app. And I was like, oh, right, I have a jar file. So I now need to, but I have to have a container to deploy it here. So, all right, okay. So I have the jar file. It should be easy for me to get my jar file into the container, but what base image am I going to start from? Go to spring.io and do a little Googling and find out, oh, okay, this is a good base image to use. Grab the base image and said, great, now I've got the base image. Oh, right, I need to write a Docker file. So I wrote the Docker file, and I ran the Docker build command. I was like, okay, now I've got my container. Of course, it's kind of in the Docker engine, and what do I do now? Oh, yeah, right. I need to upload this into Docker Hub, and I uploaded into Docker Hub, and this is several months ago. It was still relatively new for me, so here I am doing a little bit of yak shaving as I go along, uploaded into Docker Hub, and then I said, all right, now I create the YAML file, and now I do a kubectl create -f YAML file. That is part. You'll notice now I've got this container now that I can deploy on PKS. I can deploy it on GKE. I'll talk more about that in a little bit. But you can see that I had to do a fair bit of yak shaving. So I had to take on more responsibility for that. With Cloud Foundry, I take the jar file and I say, here is my code. Run it in the cloud for me. Thank you. Exactly. So when we talk to our clients about this, what we do is we have them really be very, very deliberate about this. We have these conversations and say, you know what? You get more developer efficiency by pushing further and further into the center part of this. And it is an opinionated platform, so you get more flexibility as you go out, but with more flexibility comes more responsibility. Boy, I just feel like I had a talk with my teenager. As you're growing up, you get more privilege, but with that comes more responsibility. Flashed on that. So our strategic goal is to push as far to the inside as possible because effectively we do more for you. All right, so let me get a little bit more concrete and talk about what PKS is then. So PKS is fundamentally delivery of managed Kubernetes clusters. Now, what is managing the Kubernetes clusters? Any other Bosch fan folks in the room? Woo! Bosch. Bosch is managing it. So for those of you who don't know Bosch, Bosch is a lifecycle management system that we use to manage the Elastic Runtime, so to manage the PAS system. Bosch has been in production in large corporations for the last 4 years or so it is a battle-tested system. Borg comes from, it was originally developed, incubated at VMware by 3 engineers that Paul Moritz pulled away from Google from, what I hear, exorbitant amounts of money. But Bosch stands for Borg++. R plus 1 is S, G plus 1 is H. So Bosch is Borg++. So it is very similar to the system that Google uses to run their 2 million plus servers in production. And so and it does full lifecycle management of these clustered distributed systems. And so Kubernetes is a clustered distributed system. Bosch also, so it's managing these clusters. I sometimes say it manages clusters looking up. It also looks down and acts as an abstraction and as a mediation layer down to the infrastructure. So it's a multi-cloud lifecycle manager of the clusters that it looks like up above. Now, when it comes to any kind of a platform, be it PAS or PKS or anything else, standing up the platform, while it may be challenging for some platforms that you're looking at, that is dwarfed by the challenge of day 2 operations of these systems. So day 1 may be hard, it may be easy, but day 2 is really hard. So what happens when you have to patch? You have something like Heartbleed comes along and you need to patch the system. What happens when your best guess at capacity needs were wrong? That never happens, right? And we have to scale the system. What happens when there's a brand new release of Kubernetes and our developers are already screaming for it and I'm telling them it's going to be 3 months before it comes out and they're revolting and going to GKE or some other external shadow IT service. And all of these other operational characteristics. A node goes down and it wakes me up at 2 in the morning on, after 4th of July. Not a happy thing, right? So day 2 operations are really kind of the long tail of everything. And so that's exactly what Bosch was designed for, was to allow you to do that against these clustered environments. So what we have is Kubernetes, so PKS is fundamentally Kubernetes powered by Bosch. And I won't go through those in a lot of detail, but you can see here on the laundry list on the right-hand side, Bosch does all of this and more. So when I say lifecycle management, I mean a lot of different parts of that. And so again, going back, here's a Kubernetes cluster. We're starting to drill into the architecture just a little bit. We'll call it marketecture, right? Master, workers, etcd. Fred's going to do the real architecture in just a little bit. All right, so let's, again, kind of click in a little bit on exactly what PKS is. So PKS, at its core, is open source. There's an open source project called Kubo that was originally built in collaboration with Pivotal and Google. That's right, Google. The very company that brought Kubernetes out into the open source community partnered with us because while they have GKE, which is their managed Kubernetes offering, and we heard Kim and Megan talk about that this morning, for on-prem, and their customers are asking for on-prem solutions, by partnering with us, are saying, you know what? We use, and I was recently in a meeting where we had somebody from Google presenting. It was an internal meeting. And one of the people in the audience said, what do you use to manage your GKE clusters? And he was talking about how everything is open source around Kubernetes. And when he was asked that question, he had to kind of go, oh, well, that's Borg. And Borg is not open source. People think that Kubernetes is the open sourcing of Borg. It's not. Borg has not been open sourced. Kubernetes is the container orchestration system that sits on top of Borg that provides that other level of abstraction. So Google partnering with us on Kubo is a recognition that we have the secret sauce that we need to be able to do this on-prem, the way that they do it in their cloud. So that's what we did. We launched it in early part of this year, and then importantly, we donated it to the Cloud Foundry Foundation. So you saw Chip Childers talking this morning from the foundation. We have donated the project there. What it does is it fundamentally gives you a Kubernetes cluster that is managed by Bosch, and I'll have a picture in just a moment. So if you remember the day 1 and day 2 slides that you had over there, it gives you all of that by the very nature that it's Bosch deployed. Now, from a picture perspective, here's what it looks like. What you get with Kubo, the open source project, is you get the stuff that's on the left-hand side. You get a Kubo release. So the way that Bosch works is Bosch gives you a package. It basically gives you a package. And in that package are fundamentally 2 things. Number 1, what are the bits that you're going to install onto the machines that you're going to run? So it's going to give you the bits for the masters, the bits for etcd, and the bits for the workers, and a few other things as well. So it just gives you the bits. And then the second thing that Bosch needs in its packaging format, so it's not just a packager of bits, it also needs the automation around, once I've laid down those bits for you, what do you want me to run? What are the executables? So it's the bits and the processes. And you hand those, and that's what we've defined in the Kubo release. So we have said, here's the bits, the tarballs for these things, or you can set it up to build from source. Gives you all of that. Then it also gives you the scripts so that you hand all that over to Bosch, and Bosch says, great, I know what to put where, and I know what processes to start. And Bosch takes it from there. It's a declarative way of standing up these clusters. Now, what you do with that release is then you have to create what's called a deployment manifest, and that deployment manifest fills in some parameters. It fills in parameters from the infrastructure. Remember I said Bosch looks down? It fills in details from the infrastructure, and then it also fills in details of the things looking up. How many workers do you want? How many etcd nodes do you want? How many masters do you want? What are there secrets that you need to insert for those components to talk to each other? All of those parameters. So you generate that deployment manifest, then you hand all of that over to Bosch, and Bosch stands up the cluster. Okay? What you get with Kubo is you get the Kubo release, and you get some scripts that are going to help you create that template. But it's in a dotted line because it's up to you to put all of that together. Okay, so the fundamental pieces are there, but you have to put it together. And you'll see why I emphasize that in just a moment. All right. Now, Pivotal Container Service is a commercialization of this open source project. Just like with Cloud Foundry, with the Elastic Runtime, it is an open core. So we are not going in and forking and extending or anything like that. We are taking that open core, and everything that we build around it is around helping you operate that open core. It's all around the operability and the integration of that open core. What you get is then we're giving you Kubernetes, so you get the Kubernetes dial tone. That's what we're essentially delivering. But then you get a control plane that helps you generate that Kubernetes dial tone. So you get a provisioning engine, you get self-service provisioning, which I'll talk more about in just a moment. You get update automation. So new version of Kubernetes comes out, we can turn the crank and you can upgrade it. Load balancing, networking, persistence, multi-tenancy. Those are some of the things that we're adding around the edges. And we'll talk, Fred's going to talk a fair bit, for example, around multi-tenancy and how we're doing that. Now, this is a joint development effort between Pivotal and VMware. And I'll have a slide in just a little bit where you can see how these pieces are coming together, different assets that are coming together to form the broader PKS. So going back to that picture then, very similar picture to what you saw before, except that now it's not a dotted line saying no power cord included. We're actually giving you the power cord. So the power cord that's going to orchestrate that whole thing on the left-hand side, that's all a part of it. And so this is what, again, does that picture. It automates that provisioning engine. You have the ability now to make this API that you can use, an API to orchestrate that whole thing, to kick off that whole thing. It's create a cluster, you can decide to give that ability to create clusters to whoever you'd like. So do you want just your sysadmins to be able to do it, or do you want your developers to be able to create their own clusters? It's up to you. So that's what we're allowing you to do. Now, the important thing here is that when you start to stand up a whole bunch of clusters, who's managing those? If you had to scale your operations staff as you scaled out the clusters, that could be painful, right? Instead, what we use Bosch to help it so that you can end up with a small number of people who are managing the PKS environment, and so that Bosch can manage the Kubernetes clusters themselves. And then this is just a very high-level picture. Fred's going to go into the details. But just to give you an idea, another thing that we do is Kubernetes is a highly pluggable system. So if you look into Kubernetes, how many people have done much with Kubernetes? Okay, maybe 20%, 15%. So Kubernetes, what's really fantastic about it is that it's a super pluggable system. So it doesn't give you networking. It doesn't give you a cross-node networking, but it gives you the hook points for network, to hook in your own networking solution. It does not give you a load balancer. It gives you the hook points for a load balancer. It does not give you persistent volumes. It gives you hook points for persistent volumes. So it's a very pluggable system. And that's part of what we're doing with PKS is we are giving you the pluggability. We are giving you some of the plugins that are going to snap into those spots so that when you're using PKS, you get a networking solution as a part of it. Because otherwise, Kubernetes is built so that containers on the same host can see each other and are networked, but there's no cross-host networking. That's something that you need to bring out of the box. And so we're bringing a networking solution as well. All right, so another kind of architecture diagram to see what this actually is what I've talked about so far is what you see in the blue boxes, so Bosch controlled Kubernetes, as well as the left-hand side that says PKS controller. A number of other things that are part of PKS are right next to it on the lower right-hand corner is something called Harbor. So when you have these containers and a vulnerability happens, or maybe it's even one that you're allowing your developers to create at some point, at some level, create their own containers, you're never going to run those containers in production if there's a potential risk to your production systems. So what you need is you need image scanning. And you also, remember in my story earlier where I said after I did the Docker build, I had to push it up into the Docker hub? You need your on-prem Docker hub. So you need a repository. So Harbor is an image repository with built-in vulnerability scanning. It's based on an open source project that comes from VMware. So this is one of the assets that's being brought in from VMware. Another thing that you heard Kim and Megan talking about this morning was the GCP service broker. And there's one thing that I want to kind of go back to that point, and that is, those of you who are PAS users, you're already familiar with the service broker API. So you're familiar with the fact that when I deploy code into Cloud Foundry, I can say create service, bind service. And so I can bind my RabbitMQ or my relational database into my app. On the Kubernetes side, as you're deploying apps into Kubernetes, wouldn't it be nice if you had that same abstraction so that you can do that binding? That binding really is an application configuration. It's a way of configuring your applications to these external services. And so Kubernetes, as in the open source community, has created a special interest group that they call Service Catalog that is embracing the Open Service Broker API. So this very same API that we use within Cloud Foundry is being used to allow you to have that same create service, bind service experience from within the Kubernetes ecosystem. So the GCP service broker is included as well. Let me be clear here. That does not mean that the GCP service broker is the only one that you can use in the environment. It just is one that we're bundling because we think you might find it useful right from the beginning. And Google would love us to have it there. And so we're partnering with them. So it's a good thing. You can bring other service brokers in as well, just the same way. And then finally, on the far right-hand side, you see NSXT. NSXT totally rocks. The thing that makes me so excited about NSXT is I talked about that network overlay that you had. Well, what you want to do is you're going to want to run different tenants in your Kubernetes ecosystem. And many times, I've spent the last 4 years talking to customers about, well, when I deploy this app over here, it needs to be in its own network space. It cannot share a network space with any other app because of regulatory requirements or whatever the case may be. And today, the way that that happens is you have to go provision that network. And remember I said that Kubernetes is pluggable? Then you have to plug that network into the Kubernetes tenancy and all of that stuff. What NSXT does is it's software-defined networking. You create a cluster, you get a subnet, and a virtual switch and a logical switch, or router. You create a namespace, you get your own subnet. So that's the way it works. So it automates all of that pluggability stuff into Kubernetes. Really, really cool stuff. All right, I'm almost done. I want to talk about this. You might have heard this already mentioned. I think even Ansi mentioned it yesterday, is this constant compatibility. And what this slide does is it actually, what it's hinting at is this ability, and it's exactly what Kim talked about this morning, is this ability to take a workload, and in fact, Megan showed it, take a workload and it runs fine in GKE, and I can put it in PKS and it runs fine there, and vice versa. And you might be thinking, well, I don't care about that because I'm not going to use GKE. But the answer is you care anyway. Because constant compatibility is even more so an expression of SLAs. It says, when a new version of Kubernetes comes out, how quickly am I going to be able to make that available to my customers, my developers? If you take a look at it, we have a great spreadsheet where we're tracking it. New version of Kubernetes comes out, makes its way onto GKE within days many times, maybe a couple of weeks. So constant compatibility, by saying we're constantly compatible with GKE, is we are holding ourselves to that same bar. New version of Kubernetes comes out, we're going to get it to you wicked fast. So that's really what this is about. All right, so I already gave you kind of a picture of this. We talked about Harbor and NSXT. I also want to mention that some of the other things that we're plugging in, of course, are things like vSAN, so other things that are coming from the vSphere. vSphere has been supported via Bosch. That was the first one that we supported right from the get-go. So that's been there. That's battle-tested. vSAN is something that you're going to be able to plug in as well. And then when it comes to deploying workloads into Kubernetes and managing those Kubernetes clusters, you need some tools to help you operate. Operate the workloads, operate the clusters. Keep an eye on them. And VMware has a whole host of tools that they've been using to help their customers do exactly that on VMware-based systems. So we've got a whole suite of management tools on the left-hand side that are being brought to bear as well. What's coming in the PKS box is what's in the green, but all of these integrations are going to be available as well. And finally, what I want to do is come back to this notion of, all right, can you use, here's the question you might be thinking about asking. Do I need the Elastic Runtime, PAS, to run PKS? And the answer is no, you do not. So notice that everything that I talked about was about managed Kubernetes. I can run PKS completely independently of what you know and love as PCF and the Elastic Runtime today. But if you have both, they will integrate. So you'll be able to, from within the application runtime, launch clusters and leverage those clusters and have those applications talking to each other via service brokers and those types of things. We're also going to be bringing, and there's it's an Ansi slide. We could all want to have Ansi slides, right? They're always so beautiful. Is this notion, this really kind of sums it up, is to say the application service on the left-hand side, PKS in the middle, and the data services, and then, of course, increasingly more and more services that we're going to put under the umbrella, have this shared logging, shared networking, shared security, so you get all those benefits. And that is the end of that part. So what I'd like to do is bring Fred back up, and he's going to go really deep under the covers for us. Thanks, Fred.
Thank you.
Here you go.
Okay. Awesome explanation as always. Okay, so let's get ready to go a little bit deep on technology, on how all of this work together in different pieces. So first thing that we need to understand is, for understanding how this all works, is the principles was built on. And this is a lot of what we learned on running Cloud Foundry for enterprise customers over the last 40 years or so, which is basically main principles, make sure it's always available and resilient. So it's production ready from day one. It's always available. It's really hard to have anything that you can't really repair. We'll see that Bosch keeps the things going at every single circumstance. And that just makes it a very rock-solid product. The second thing is operational efficiency. Like, if you're moving really to a platform, the number one thing you expect, other than be able to help your developers pushing their code to the cloud, is be able to operate efficiently. That means instead of having your current dozens of people to operate a small or medium-sized cluster, you expect to have much less people. You expect to have much more automation built in. You expect to actually leverage a lot of what you've done for other systems. And you expect to handle much more configuration and proactive monitoring, proactive capacity planning, other than looking at things as they break and trying to fix them and working out of 27 different scripts for managing different environments and try to make sure they're all synchronized when you update a version of a product. We not only want availability, resilience, and operational efficiency, but we want to make sure that you're secure, that this thing is compliant to whatever your security department expects. From what Cornelia mentioned, maybe it's a Docker image scan. They want to make sure there are no vulnerabilities included in that. Maybe it's making sure that you have the most updated system at all times. So constant compatibility with GKE helps that a lot. Exactly make sure that as you deploy code, you can isolate workloads from a network point of view, from a node point of view, so they actually are secure. The workloads that need that extra layer of security are isolated from the other ones that don't need it. It's make sure also that you have multi-tenancy isolation if you're supporting multi-tenants. And I'll show you that you have multiple ways of doing that with PKS. And the last thing is make sure it's extensible. If we actually give you access to Kubernetes, which means it's gonna have a little bit more of do-yourself than Foundry, application runtime, as Cornelia explained, you won't be able to leverage that and build extensions on top of it. So I'm hoping to explain some of this over the next few slides. So let's look at PKS in the big picture, right? Cornelia already explained some of this. We'll have Bosch underneath it all as actually the layer that looks up to what it needs to deploy and looks down in the infrastructure and connects all the pieces from multi-cloud world and makes sure what deploys keeps running. And we have the control plane of PKS, so PKS controller in front of it, which when you can get to it and say, create a cluster. And if you want to create a cluster, you target the control plane. What's going to happen is Bosch director or Bosch, they're interacting, can target multiple availability zones and then deploy Kubernetes on it. And you can have, for example, your nodes and your masters deployed to different availability zones. And there it goes, the first level of availability, which means even if you lose an entire availability zone, you have your workloads spread to multiple. In on-premise environment, that usually means multiple vSphere hosts. You could use the entire host, and you still run your applications. Load balancer takes care of it, sends all the traffic to the node that is still alive, or the availability zone is still alive, you're still in the game. But as Bosch does that, it also puts an agent inside each of the nodes or each of the VMs that it's deployed. And that agent is actually responsible for watching every single process. It starts and watches every process inside those VMs. So if you lose a VM, Bosch will redeploy that VM for you. Easy. But inside the VM, if a process dies, the Bosch agent is going to restart that process. And that's something that if you're just trusting on the infrastructure layer, it can usually redeploy VMs because it knows the state of the VMs, but it has no clue what's running inside that VM. So it's something that really Bosch excels in. And then, of course, we have Kubernetes, that if you ask to deploy a pod, you have the controllers that are actually watching those pods and talking to the nodes, and then you have kubelets making sure the pods are all running and restarts those pods if necessary. So you watching every single thing from the pods to the processes to the VMs and make sure you're deploying to multiple availability zones. and Bosch takes care of it all. So that answers a lot about availability and resiliency of the system. And let's say you have deployed it. So now you have a beautiful Kubernetes cluster running on PKS with all the components that we talked about, Bosch managing Harbor, NSXT bits, service broker, and the Kubernetes cluster. And then let's look better on Kubernetes and try to understand how these things work here. A disclaimer, as I know, most of the room has some knowledge about Cloud Foundry. Some of you have touched Kubernetes. I'm going to talk about it like I talk to Cloud Foundry people, so we have a better understanding. We'll make some comparisons. They'll also help you understand better from a technical point of view why one is more suitable for some cloud-native or almost cloud-native workloads. And the other one is suitable for exactly what you don't run that well in Cloud Foundry nowadays. So if you look at the Kubernetes components or Kubernetes high-level architecture, you already said that we have masters. And the master is basically what keeps the state of the cluster. It's backed by something called etcd. It's a key value store that stores the state. And it talks to the different workers. And the workers are actually the ones who actually run the workloads. The two things that I like to highlight usually, and then now we're talking about extensions, is that Kubernetes has a very pluggable network interface, and we call it CNI. And so you actually plug your what we call a CNI plugin or the network plugins. They will actually help connect the different nodes and implement what you want in terms of networking. I'm going to talk more about that. The other pluggability point is actually persistent volumes. Kubernetes will also allow each of its pods. And pod is a unit of deployment of Kubernetes that can include one or multiple containers inside it, that you can actually plug pods directly into persistent volumes. So you can access from your GCP disk, for example, to your AWS S3 storage, or maybe even your SCSI or a fiber channel if you're deploying, let's say, a distributed database on it. So that's a bunch of really cool things. So look first at networking. There are a lot of what we call CNI plugins or network plugins for Kubernetes available. Why using NSXT, and what do it actually give us? Let's open it a little bit more. So as you deploy PKS, you're going to have the basic Bosch network with one different IP address assigned to each of the nodes deployed, or each of the VMs, in this case, deploying the VM system. Or we can look at it in a different way. Each node will have its own IP, and this is what we've been calling the base network. If you look at the base network, every single worker will be actually hosting pods. And those pods, as you deploy them, they basically get an IP, an internal IP from the Kubernetes cluster, which is addressable anywhere in the cluster. But actually, the network between the workers is not connected. That means that inside the cluster, if you have that connectivity, you can access any running pod by their IP address if you plug something that connects them. It also ships with something called Flannel, which a lot of people use. It's the most basic CNI plugin in the Kubernetes. And what basically Flannel does is just connect all the workers as a flat network. So as you deploy a pod, it gets an IP that's addressable inside the cluster, but again, it's addressable inside the cluster, anywhere. As it is great because you have easy access from one container to the other, if you get access to one container in the cluster, you can access anywhere in the cluster. And it doesn't look like your security guy in the company will like this kind of thing. So what we do is basically we plug NSXT. And what NSX will allow you to do is to have one separate subnet, which is implemented as a logical switch per namespace in Kubernetes. And namespace in Kubernetes actually controls everything. You create a namespace, you're like creating your own logical piece of the cluster. So NSXT will give you a separate subnet per namespace. And that's what we call overlay network. So you have your 10.0 subnet by Bosch, for example, that gives an IP address for everything that Bosch deploys. And then you have an overlay in this case, a 10.172 network, that NSXT will create multiple subnets, one per namespace. And as you deploy the pods, and they are assigned to a namespace, they get an IP address from that namespace it belongs to. And if you deploy pods to different namespaces, they're just going to be part of different subnets. And then from NSXT, you can control which one access which other, how things work, where your virtual firewalls are in general. And what it gives you is the possibility of, first, defining network policies. And network policies are something that account Foundry users are very used to. And I'm going to show an example. But that means I want this specific set of IPs to only listen, to only be able to access from outside over these ports. And I'm going to blacklist every single IP that is not based on that range. And this other port here can be used as egress, but not as ingress. And you can actually configure all those specific policies, target to specific namespaces, any specific labels that you put in your containers, so you can have very complex policies, and NSXT enforces them. The way the CNI plugins work, you actually never need to go to NSXT to define those. You deploy the network policies to Kubernetes. There's just standard Kubernetes deployment descriptor. NSXT watches it, and as it sees you deployed something, it go fetches the configuration and apply to the nodes. You don't even know it's doing. And then obviously, those things that are deployed, so as the logical new switch is deployed, as you create a new namespace, those are deployed by Bosch. What does that mean? Anything goes wrong, Bosch redeploys it. Bosch keeps an eye, health checks, redeploys it every single time. So the high availability pieces also applies everywhere here. Once you get network policy management, it starts to be much easier to talk about multitenancy. Because I'm going to show you there are basically two ways you can do multitenancy. And for one of them, you definitely need this kind of characteristic. And then you can also apply network security groups, which are a little bit different than policies. And then you can start talking about load balancing and ingress for routing. I'm going to explain a little bit that. And if you are a VMware admin and if you ever use an SXT, you can actually have a very comprehensive VM plus container security model. So whatever you define for your VMware cluster, you can leverage the exact same policies in Kubernetes mapped to those namespaces and mapped to those tags that you put in your containers. So this is an example for policy management, right? I'm sure you cannot read it. It's very small, but I'll give you a hint. So there's a deployment descriptor on the left that basically says, for this kind of IP addresses, so for this network range, I'm going to allow for this project and those kind of containers access to the port 6379 on TCP, for example, but I'm going to block everything else. So you basically deploy that. You target your Kubernetes master that was deployed by PKS. You're going to say, go apply this configuration. This gets picked up by the master, apply to TCD. NSXT is watching it. It picks it up and applies to the NSXR router that is running in every single node that was deployed by Bosch. And then it applies the configurations automatically for you. So I mentioned multi-tenancy a couple of times. Once you understand that every single namespace gets a different subnet, it makes it easy to understand there are two options for making multi-tenancy. One of them is just use the control plane or the controller to create multiple clusters. And you can then assign different clusters to different tenants. And I think this is going to be especially useful for workloads that you really want to make sure are isolated. Maybe if you have some workloads that are normal, the other workloads are PCI compliant, most likely your security guy or gal will tell you, this cluster needs to be isolated from everything else. Because even if you have network policies in place, I don't want to run a chance that you deploy just a container that you got somewhere that has some vulnerability that we haven't found out. Somebody gets access to that node and access the other containers within the same subnet or even the same cluster to the different network, not to the overlay. And if they do that, they can get access to the other apps. You don't want it to happen. A lot of times you really want separate clusters. Obviously, there's a balance. You probably won't end up with hundreds of clusters because it's hard to manage, not only for you, but you have Bosch managing hundreds of clusters won't make much sense. But it makes a really good sense for some specific multi-tenant scenarios where you really want to have completely separate clusters. Understand that having a separate cluster means you have a separate master. And as the state and the configuration of the cluster is on the master, you can even leverage a different network model completely for a different cluster. You can leverage completely different objects deployed for configurations. But then, obviously, it's more things to manage. But then, if you have an SXT with kind of network segregation, it allows you to have actually one single cluster and give every single tenant access to a different namespace, which is a lot similar to what we do with the Pivotal Application Services or Elastic Runtime and have different orgs. So users can belong to different orgs. They can have different levels of access to different orgs. You can have the same for different namespaces. And then you have an SXT enforcing that you have completely separate subnets, and the containers deployed to one namespace will not necessarily access the other namespace truly. So different choices for different kinds of needs from customers, different kinds of workloads, different kinds of use cases and scenarios. Make your choice. Just to understand how this works with NSXT, for example, you can say, go to kubectl with the Kubernetes command line and create 2 namespaces, and then just run applications on the different namespaces. When you do that, what's going to happen is Bosch is going to go there and deploy logical switches for NSXT, and they get different subnets. And then once you deploy the applications, they will get IPs that are actually related to those subnets. And they're completely isolated. Logically, they are isolated. They might be running still on the same worker nodes. They are completely isolated from a network perspective. And that's what software-defined networking allows you to do. And then, if you want to leverage security groups, and I'm not going to go deep on explaining how security groups are different than policy management, but we can talk offline if you want. This is something that the VMware admins should be used to. You can actually tag your containers and deploying with specific labels that are going to be bound to specific security groups in an SXT. And then SX will also enforce that. So far, I've explained high level how Bosch deploys Kubernetes, how it deploys the other pieces as well, how it keeps them running regardless of what happens in many different levels, and then how we offer an SXT as a pluggable networking, and why it's important to leverage an SXT, especially if you want to do multi-tenants on a single cluster, if you apply network policies, et cetera, et cetera. But essentially, let's remember, what a network a plugin allows you to do in Kubernetes is connect multiple worker nodes that are not connected and make sure things actually flow. It can actually route to the applications you're running and connect several instances that are actually on different worker nodes. So if you don't know exactly how Kubernetes works on that, got you covered. Let's look at how it works in PCF, and then it's going to make more sense for you. So when using the application runtime, or what we used to call PCF, what basically you give it is an application, let's say a jar file. As Cornelia said, here's my application code. Run the cloud for me. Bingo. So what you get a route directly mapped to your DNS. You click on it. It will route directly to the multiple containers instance you're running. Dynamic load balancing, everything works. But then you're going to do the same with Kubernetes. Again, Kubernetes allows you to customize a lot of those things, so it doesn't come pre-baked. When you run kubectl run and you give it a container, it will say container running. Cool, so how do I get access to that? So there's no public IP. You get an internal IP from the cluster. There's no route, right? It will basically pull an image, let's say out of Harbor, if you're leveraging Harbor. The master will do different things here. Waving its hands will talk to the worker. Kubernetes will deploy the nodes, the pods. And then what? Well, let's remember, every single worker will actually have a pool of internal IPs that are going to be assigned to the pods. And then I represented it as a dashed line here. They would be connected through a conceptual cluster network, and that's what the plugins do. So if you want to access it, you can leverage what Kubernetes calls services. So enter Kubernetes services, which please don't confuse with what we used to call services in CF, which service brokers. Services in Kubernetes are basically network constructs. They allow you to route to running containers in a different ways to allow you to customize what Foundry does for you without you even knowing the Foundry application runtime. So different kinds of services. Most people who deploy Kubernetes on their own, they used to leverage node ports. And essentially is, if I deploy a container, it says container running. I say, now please expose this container for me as a node port. It's actually going to open a random port on every single of the worker nodes. High number port, let's say 5642, on this worker node that has the IP.1. And then if I target the IP.1 and this port, it will basically forward to the running container internal IP that it has inside that cluster. It's a lot of plumbing if you want that to work, because you got to know what exactly the worker IPs are, which ports are, and then configure that, for example, in your external load balancer, if you want to do it. But then if you deploy a new worker, you got to add that to the pool of your load balancer, and you need to keep track of the open ports that you exposed it. What people do in GKE is what we call a dynamic load balancer, or a cloud load balancer. It's a different kind of service. It's not a node port. But it relies on the cloud provider or the network provider being able to dynamically provision a load balancer for you with a public IP. So let's say I deploy my containers and I want 4 copies of my image. It will give just 4 different internal IP addresses, not accessible from outside of the cluster. And I say, now I want a load balancer. Expose this through a service type load balancer. Somehow, somebody's going to do some black magic, is going to bring a dynamic load balancer with a public IP that forwards or routes to those running containers for you. But again, who does that? GKE does that for you. Azure does that. AWS does that. If you're on your premise, what are you going to leverage to do it? Well, NSXT does that, which is pretty cool. On the same way that it stands up a logical switch for every single namespace as a software-defined networking construct, it will dynamically provision a load balancer for you, which keeps track of the running containers and will load balance between them for you. And you get an addressable IP outside of the cluster that just forwards that, and everything just works. Now the Kubernetes community has been working a lot on something that is still incubating, but a lot of people using. It's called Ingress. And it's a way to not only define a service, but on the same manifest, and this is the kind of the future of services for Kubernetes. It was to be at least. People are defining access rules, virtual hosts, and services on the same manifest. Right now, if you want to make Ingress work by yourself, you got to deploy a bunch of NSX or NGIX containers and plumb it yourself and do some bunch of configuration files. But if you just deploy this, NSXT will do that for you. So another huge advantage, another big reason I'm a super fan of NSXT. And then, now not necessarily talking about NSXT anymore, you also have the chance with PKS to have a deeper integration with the application services or with the PaaS if you're using it. So if you're an existing Cloud Foundry user, you want to use PKS. And what that special service kind does, which is what we call route sync, it updates the Cloud Foundry router, the Go router, and the TCP router, using both, automatically with the addressable IPs of your Kubernetes cluster, and then you can just get a URL like you get in CF. Obviously, there's a trade-off because all your traffic will go to the Go router. So you might need to add a few instances and scale your Go router as you go, but it's just a super easy way to do it. Okay, so that's a little bit of PKS networking. Why we're leveraging NSXT, what the benefits it brings. And I think it's super clear that depending on what you want to do with Kubernetes, especially if you want to leverage multitenancy with specific network policy control and security groups, and you want to be able to use dynamic load balancers, it's a really good choice, and that's why we're embedding it in the product. Now, the other way to expand Kubernetes or customize Kubernetes is basically just by bringing different persistent volumes. And the community has worked a lot on this. As Cornelia mentioned, we bring in vCN as part of VMware. But Kubernetes, just by Kubernetes, you can just get any pod you want. And as you deploy it, you can attach it to different volumes. And I talk about this because, for me, it's one of the main things that tells you why a use case would be deployed on Kubernetes instead of the application platform of PAS. Because once you really want to leverage stateful volumes, and this could be for different reasons. It could be because you're deploying a clustered stateful workload, like a database, a distributed data grid that really needs a stateful volume. It might be you're doing some distributed database. Let's say you need access to a fiber channel connection directly, and you can do that with Kubernetes. And there are ways that if a pod gets rescheduled, the volume just gets detached to the old container and reattached to the new one. So everything just works. So you can just deploy as you're deploying a container. You just say volumes. This needs access to this GCE volume, for example, from GCP. And you say what's the name of the volume and where it's supposed to be mounted on. And it just mounts. Now, why would you use this? And I'll get back to that really soon. Why would you use this? Well, imagine that you have just not only a data service, but you have a legacy app. And one of the main types of applications that were really hard to support out of the box at the application runtime are just applications that relied on specific volume points and volume mounts and needed access to stateful volumes. Once you start pulling that, you're going to find a huge number of use cases which have very, very specific needs. And those needs, most of the times, they don't stop at, I need access to a volume. Because I need access to a volume at a very specific mount point, /var/my data1, whatever. And maybe that's the mount point where your database stores its stuff. Or maybe it's where your middleware is storing their, I don't know, their messaging save points. We've been seeing people deploying WebLogic directly in Kubernetes, the entire WebLogic thing. And if you ever installed WebLogic, you know how hard this thing can be and how picky it could be with configurations. And that's why once you have persistent volumes, you can start leveraging some of the stuff that you already do in terms of operations. Like you can have an admin that register different volumes, add them to the Kubernetes pool. So I have a volume that is NFS. I have another one that is a fiber channel. They're only available for this specific namespace. I have this other namespace where I deploy my databases that they're using these SCSI disks, and they're all leveraging Kubernetes volumes. And then as your developer goes and asks to deploy a volume, they can just request a claim or a specific part of what your admin has provisioned. So that life cycle is already available in Kubernetes as different commands that can be assigned to different roles. So you can make this work. So once Cornelia said, we only had this many applications or this many kinds of workloads that we could support on a pivotal application service so far, and they had many different reasons. Because they had specific ways to start and stop the application, the containers, and they have specific orders of doing things. And they relied on specific stateful volumes mounted on specific points. And again, containers are ephemeral. And maybe they needed access to specific ports that you're not exposing, not necessarily HTTP ports. And you want to make sure that when you're exposing 3 different ports, one of them exposed externally, the other ones are internal to the cluster to communicate. And you want to make sure those network policies are put in place and that all that network isolation works. And then you can enter what we call stateful sets, which for me is one of the coolest things in Kubernetes, which is a way to specify workloads that have stable network IDs or IPs, stable persistent storage, and ordered deployment, updates, and scaling. And when I say stable, it means I kill a container, it restarts with the exact same IP or network ID. And if you ever configured, let's say, a database, you know that's a big deal because you go to the master and you configure, let's say, the IPs of the segments. And you don't expect that IP to change. And the segments have a specific mount point for their volumes. And if you restart it, you expect it to be reattached. And if you're doing an update of that, you have a specific order that the things must be updated and this must be brought up back in place. And how many legacy apps that you run today that have those characteristics? A huge chunk of them. And you might be talking about ISVs apps, you might be talking about middleware, you might be talking databases, stateful data sets, and being able to deploy Kubernetes, managed by Bosch, leveraging all that operational capability that you have with that level of operation efficiency, allowing to do this kind of things, opens up the rest of the slices of the pizza they weren't able to grab until now. And that's why we bring in Kubernetes as PKS. With that, we're going to open for questions. Cornelia might want to be back to help answer those. Yes, start with you maybe.
So if I deploy an application into Elastic,
Yep.
and I build a service endpoint in Kubo, can they connect them?
So just question, quick, repeat that. So you said you deploy an application to the Elastic Runtime, and
I deploy a service endpoint into Kubo,
mm-hmm.
multiple platforms behind that service. Can I
Absolutely. You want to reply to that?
Yeah, you absolutely can. So the first thing is you treat it essentially as a service that's external to the ERT. So you would use user-provided service instances to do that binding. The only other thing that is it has to be network accessible. So one of the interesting things that you can do with network segmentation is your network segmentation doesn't need to just span the Kubernetes cluster. You could have network policies like Fred talked about that say, hey, allow this service to be accessible from the network that is running workloads inside of ERT. So the same rules apply in terms of network connectivity has to be there. But yeah, you get an endpoint. As soon as you use a node port, for example, and you have a load balancer connected to it, then you can use that as the endpoint that you bind via the via user-provided service instances into your application on the app runtime.
Is Kubo the service within the org, within PCF, so
Okay, so your question there was around the Kubernetes clusters that we're provisioning, or maybe even the workloads that are running, are they within the org? So at the moment, for the very first release, we aren't bringing orgs and spaces. Remember I said that you could run PKS separately? We are, by the very next release on the roadmap, is planning to have that connectivity back. So you would have orgs and spaces providing an IAM boundary, if you will, that governs all the way out to the Kubernetes clusters.
although you can use the Go router from PCF to be your ingress point to Kubo,
Yep.
there's really no relationship between the two clusters, right? So you get your ERT cluster,
That's right.
containers, and then you can deploy Kubo cluster.
Yep. Yep, exactly right.
Except that there's also NSXT integration with pivotal application services. And if you have NSXT across everything, then you can start defining policies that will apply to everything.
Yep. So.
And then things start to make sense, and NSXT can actually forward that traffic for you.
Yeah.
We can get deeper on that offline.
Yeah. Yeah, we'll definitely post the slides for sure.
Definitely make that.
For sure. So Fred and I will stick around for a little bit, but I think we need to clear the podium for the next speaker. So we'll take questions outside, and thank you so much for your attention.
Thanks, everyone.